So we are continuing with linear stuff in the next couple sections. Today we're focusing on linear equations, so we're going to be solving some equations and talking about different types of equations. So let's start out with trying to solve a couple. If I asked you to solve this equation, what would we do first? Distribute the 3. So 10 plus 6x minus 12. What am I distributing on this one? 17 minus x minus 5. Okay, let's combine like terms. So over here, 10 minus 12, so that's negative 2 plus 6x. Over here, 17 minus 5, 12 minus x. Make sure you're not, sometimes I have people that try to like add the 12 to both of them and make mistakes that way, but remember, you only change the sign if you're adding it to the other side of the equation. These are just on the same side, so we're just combining like terms. Now we need all of our x's on one side. So I need to add this x over. And add this 2. So we have 7x equals 14. 5 by 7 and x is 2. And nice thing about an equation, what can we always do? Yeah, we can always plug it back in and check our answers that way. What about this? There's a couple different options for solving this equation. What are your thoughts? What could I do? Okay, we could get a common denominator for everything. What would my common denominator be here? 6. So we can get the common denominator. That's option number 1. What's another option? We can multiply to get rid of all of the fractions. What would I have to multiply by? 6. The same thing that would be your common denominator if you were trying to make one big fraction is what you would multiply by to get rid of the fraction. So we could multiply everything by 6 and get rid of that. There's actually a third option. We could just break everything up. Don't we only have one term on the bottom, right? So we could rewrite this x over 6, that's like a 1/6x, plus 7 over 6, and break everything apart like that. So 3 different options. Any one of those will give you the right answer. Which one do you want to do? Such a decisive group. I love when everybody has an opinion here.
What do you think would be easiest for us to do?
I can do them all.
Common denominator.
Common denominator? Well, okay, let me ask you this. Do you guys like fractions?
No.
So how about we get rid of them? You want to do that? So we said to get rid of them, we have to multiply everything by 6. So you have to do every term, which in this case is each of these fractions and my negative 4. So on this one, those 6's cancel. And we're just left with x plus 7. On this one, 2 and 6 would reduce to 3. So we're left with 3 times the 2x minus 8. Negative 4 times 6 is negative 24. Alright, take a second. I want to make sure everybody understands what we did on that step. Have I lost anything? Okay. So, where do you understand the x plus 7?
Yeah. I got lost on the 2x.
Okay. So, I was trying to reduce. We have 6 divided by 2, which is just 3. So you're left with 3 times
so
that.
Go to, okay.
Yeah, think of it as like 6 and 2 would reduce to 3 over 1,
Yeah.
and you can drop the over 1.
Okay.
Other questions?
So it will always, if you have to reduce, then it will always be on top.
Yes. All right. Now is this an equation we can easily solve? Why don't you guys try to solve that? Do you guys get negative 1? Complete opposite, different way.
Witchcraft.
Do you guys want me to show you a different way of doing this problem? Mm-hmm.
Okay, so I didn't,
Looks like we were kind of getting a variety of answers on this first one. What strategy did you guys do? Okay, so I kind of look like most of you were trying to just get rid of your fraction, right? What'd you multiply by to get rid of the fraction? 12. Well, that's interesting. Okay. You guys are seeing this. I'm not just crazy. It was on pen and then it moved it and I moved it to the cursor and it was writing. Okay, so we're going to multiply by 12. 12 divided by 4 is 3, so we're left with 3 times the x minus 2. 12 divided by 3 is 4, so 4 times the x plus 1. And 2 times 12 is 24. So if we distribute, we get 3x minus 6 plus 4x plus 4 equals 24. 3x plus 4x is 7x. Negative 6 plus 4 is negative 2. How would I move that negative 2 to the other side? Add 2, so you get 7x equals 26. Divide, so 26 over 7 is our answer. Is that one okay? Next one. All right, we have a lot of things going on here. These brackets are just like another set of parentheses. When you're working with those, you start on the inside. So first thing I need to do is distribute a negative through that. So we get a positive 9 and a negative 2x. Over here I can distribute my 2. So 6x minus 2. So we have 4 minus 2x inside that parenthesis. So negative 12 plus 6x equals 6x minus 2. Now what?
Subtract 6x.
Okay, if I subtract my 6x, I get negative 12 equals negative 2. Is that possible? So what does that mean?
No solution.
No solution. So there are different types of equations. There are equations where we get an answer, and then we just saw the case where we worked out our problem, everything canceled, and we were left with a false statement, so it was a no solution. Is it possible to have one where we have infinite solutions? Yeah, if I solved to this point and had negative 12 equals negative 12. That's true, but there are no x's left. So in that case, there are many solutions. So these are the different types of equations. If you solve it and you get a solution, that means if you were graphing these, the lines meet in one spot. That's what's called a conditional equation. So a conditional equation has a solution. If you solve it and get x equals something, that's conditional. It's true under the condition x is this number. If you solve it and like what we just got, there was no solution, that means it is a contradiction. On those, we will now, instead of just writing no solution, we will say no solution, contradiction. That is the type of equation. There is no value of x that would make it true. If you are looking at the graphs, that means those are parallel lines. They never meet. Or it's possible that we could have infinite solutions. You solve it, all of your x's drop out, and you have a true statement. 5 equals 5. That's what's called an identity. And there are infinite solutions. It means I've given you 2 equations for the same line, and every point on that line would be a solution. So you need to know the 3 types. I might ask you on a test or quiz to solve it and classify it. So if you get a solution, it's a conditional. If you get no solution, it's contradiction. If you get infinite solutions, it's an identity. So I want to decide if each of these is an identity, a conditional, or a contradiction. In order to decide that, we actually have to solve it. We're not just going to look at it and magically know. So we're just solving all of these equations. So the first one, if we distribute, we have negative 2x minus 8 plus 3x equals x minus 8. Negative 2x plus 3x is x minus 8 equals x minus 8. If I subtract my x, I get negative 8 equals negative 8. So what does that mean? We have infinite solutions. Any value of x works. So you can write infinite solutions. I will allow you to say all real numbers on this. So any value of x will work here. B. So if I add my 4 x equals 15. Divide and x is 3. So what's this one? Conditional. We have a solution. This equation is true under the condition that x is 3. This one, if I distribute my 3, we get 9x minus 3 equals 9x plus 7. Subtract the 9x, so we have negative 3 equals 7. What's that mean?
No solution contradiction.
You guys try a couple. So the first one, you got x equals 11 for your solution. And since we got a solution, that means it's conditional. Okay, second one, distribute. When you subtract 14x, you have 10 equals negative 35. So what's the solution on that? No solution. And the type then would be contradiction. Last one, if we distribute. So negative 6x plus 5x is negative x. Plus 3 equals 3 minus x. When you add the x, you get 3 equals 3. So the solution is all real numbers. The type of equation is the identity. Did we get those? Last example that I want to look at today. Say I asked you to find the zeros of this function. What is a zero when you're looking at a graph? So a zero is another word for an x-intercept. And to find x-intercepts, what do? Plug in 0 for y. So my y has to be 0. F of x we know is the same thing as y. So if I put in a 0 for that. So all I'm doing is finding when this equation equals 0. So if we start by distributing, thank you. And 4.5 times 9. 40.5, right? You guys are so trusting. Combining like terms, 1.5x plus 3x plus 4.5x. So 1.5 plus 3 plus 4.5. That's 9. Negative 12 plus 40.5 subtract over the 28.5. Divide by 9.
Three point one six three.
Thank you. Let's go ahead and just change this to a fraction since it's not a nice decimal. So if you hit math number 1, that would be so if I ask for a 0, I'm asking you to set the equation equal to 0 and solve. Any questions there? So you have a math Excel assignment.